Good morning, good evening, or good afternoon, depending where you're based. Uh, Thanks for joining this Neotys webinar series. Today it's a joint webinar with one of our partners, Apposite Technology. Today, if you look at the title of this webinar, it's 5 crucial considerations for cloud migration. Yeah, like it's written, you can imagine that we're going to talk about cloud migration. Yeah, obviously, so many years ago, people were talking about the cloud. So some people were not very confident about moving their applications over the cloud. But now, or a few years back now, you can see that most of the organizations have started their cloud journey. And if you're going to do the same thing, there are a few things to consider, of course, and this is the main topic of this webinar. All right, so just to remind, so today it's going to be around a 45 minutes webinar, and at the end, of course, there will be a Q&A session. About the Q&A, good thing is, I don't know if you're familiar with GoToWebinar, but you don't have the ability to interrupt with us today. I'm sorry about that. It's a webinar. So if you have any questions, if you have anything you want like to exchange with us today, there is a dedicated question panel in the GoToWebinar solution. So please drop your questions. We will try to look at those questions while we're speaking, but don't worry. We will have, in any case, at the end, dedicated sessions for all your questions. All right, so without waiting, I think the best would be to start introducing our presenter of today's webinar. So I will start by myself. My name is Henrik Roxette. I work for Neotys. So I don't know if you know Neotys, but Neotys is the software provider that delivers the solution called NeoLoad. So it's a load testing solution. I've been in the performance testing market more than 12 years now, and I'm working as a partner solution evangelist, which is the person that will build integrations. Otherwise, if you look at the LinkedIn and Twitter page on my own, you will see we are the Lego character. Don't be afraid. I'm just a big kid that likes playing Legos. And today, I have the honor to have Joe Detto from Apposite Technology. So hi, Joe. Thanks to be part of this webinar.
Hi, Henrik.
So Joe is the VP Product Management of Apposite, and he's been working more than 20 years of helping enterprise and services providers on application performance. So he is, I would say, he is the network expert of today's webinar. All right, so without waiting anymore and enough of speaking of ourselves, let's start the content of this today.
Yeah, hello everyone. Thanks for attending. Hendrik's coming from Europe, from France, I believe, and I'm coming from the United States, from Los Angeles. So very excited to be working with Hendrik and Neotys on this webinar on cloud migration, because I think there's there's a lot of opportunities to help organizations improve, because cloud is obviously one of the biggest things that's going on in IT that you can imagine. So I mean, we've been talking about cloud for a long time. It's the concepts are from even the 60s. Amazon launched in 2006 with their first AWS offering. So cloud is obviously very important. So we'll talk just a little bit about the drivers, but this is, we've been on this journey. It really heated up in my mind around 2010 or so. So many organizations are focused on cloud, but still struggling with it. So and it's a huge market. We're going to present a little bit about the market data, but it's already, multiple analysts say it's over $100 billion market, and some predict it to double in the next 4 years. Some are a little bit more conservative. But the drivers are pretty obvious. It's all around agility and not having to buy physical compute and storage and have it located on your premise, and having to, every time you want to scale up or scale down, deal with physical resources. So it's the ability to use a shared pool of resources in a data center or data centers, and that just allows you to dynamically add compute and add storage as you go. So you can, it takes a lot of the risk of especially for younger companies, that to be able to spin up and try out new products and new services pretty dynamically, and only use the compute and the storage resources they need, and pay as you go. And if it's not needed, you can kind of put it back into the pool of your cloud provider. So it dynamically reduces the risk to a degree, and also can handle peak conditions that maybe your business is retail and it's seasonal, and you know you're going to have a spin up. So beyond just dynamically kind of doing pilots and trials of services, and before launching big, you can also, even for more mature businesses that have peak traffic around events, they can handle that. And it all boils down to essentially saving risk and saving capital and real estate investment. So it's a cost savings move. We'll transition, and Hendrik will talk a little bit about the cloud architecture and considerations for that, and some more detail on the market projections.
So yeah, I think there is a different type of offering. So there's lots of different cloud solutions now on the market, but we're not going to go presenting and exposing them. But I think before we go further on this content, it's really important that we are all on the same page, showing the difference between, on-prem, no surprise there, we know what is on-prem, of course, infrastructure as a service, platform as a service, and last is SaaS. If back in the old days when we were deploying application on-prem, basically you manage everything. So you got the app, you have your data, you have to host this application within a server that needs an operating system, of course. You need to manage the storage, you need to manage your networking. So like Joe says, it needs some space within your organizations, and it needs a lot of people to maintain and monitor everything here. So that's what we know. That's how we've been working 10 or 20 years ago. The first level, I would say, is infrastructure as a service, and I would say that it's the first offering that most of the cloud providers came up with, providing machines from the machines, which means storage included, and network as well. So the rest you will be charged of that. So the data, the application, the middleware you install, things like this. Then you have platform as a service, and I think platform as a service is quite efficient, especially when you want to do a DevOps trend where you just take care of the app and the data. The rest you handle it into within the solution provided by the cloud provider. So it's quite helpful and help you to deploy and manage sort of the apps in the same time as well. The last offering, which is exploding at the moment, is software as a service. Here, you buy a software, and the software vendor is basically imagining everything. You don't have to worry about anything. So you only just have to worry about training your teams and maintaining and making sure that the team is using that product. That's the only thing you have to worry about. The thing is, so this is metadata and numbers that comes from a Forrester research done a few years ago. And it's interesting to see how the cloud market has changed the last few years here. Basically, SaaS is basically taking a lot of things. I mean, as you can see, most of the software vendor, I mean, like our company, Neotys, we are also moving on a SaaS or NeoLoad web as well. So, I mean, it's a reality. Everyone needs to have SaaS offering. More and more customers expect to have subscription models. So it's a key thing. But still, platform as a service is growing up as well a lot, and infrastructure as a service is still used within a lot of customers as well. So it's taking a big part of numbers, and like Joe explained, it's related to the fact that cost saving and bringing agility to our project.
And the thing is, Henrik, one comment on the market data. So that this comes from there's obviously lots of analyst firms out there, and this one comes from Forrester. Interesting, Gartner is also one of the other leading analysts in the market. So they're actually they're kind of in line with these projections for SaaS, which are tremendous growth. They actually are more bullish for sure on infrastructure as a service and platform as a service, particularly infrastructure and as a service. Their numbers for that column are significantly higher, maybe 4x on infrastructure and a service, and they project that it's growing. That's going to double as well in the future. So it's interesting to see a couple different perspectives from different leading analyst firms, which I tend to side a little bit more with the Gartner, but maybe the truth's in the middle.
Yeah, I think it's you make the point. I mean, people want to manage are building applications, and they are managing it, and they are deploying it. So SaaS is useful for, I don't know, for example, I'm not going to name any company, but if I need to build Word documents or PowerPoints, I mean, they have a great offering in a SaaS model, so I think it makes sense. Or a big CRM company. I mean, a lot of people are utilizing it because it makes sense also because you don't have to manage it. So it really depends, I think, of the solution itself. But I think if you want to pay a pay-per-use offer, SaaS makes sense. If you want to build something complex related to your model, I mean, PaaS or IaaS will be more aligned for sure.
Yeah.
The other thing is you mentioned the cost. I mean, where is the TCO of the cloud, of migrating over the cloud? I mean, here on the left side we have the iceberg with the on-prem software, and on the right side you have the cloud. I mean, on-prem, no surprise, we manage everything to the licensing, to the hardware, to the maintenance, the training, blah, blah, blah. But you can see that as the cost of the license is a small piece of the overall cost of the project. On the other hand, if you look at the pure SaaS approach here, you can see that obviously subscription is the biggest part of the cake, 68%. The rest is a small customization, implementation, and training. And some of the vendors said that, moving to those SaaS offerings, you're saving 70%. I'm not discussed about this. I don't know where those numbers come from, but still, I think there is a major cost saving by moving to those to the cloud. So, what is the first consideration, Joe, by migrating over the cloud?
Yeah, absolutely. So this brings us to our first consideration. So we've talked about the the rosy side of it, of having more agility and having cost savings, but it's certainly not without risk and not without stress. So a surprisingly high percentage of migrations do fail, or at least some portion of the migrated service or services need to move back. So I've seen some really good studies out there, and they're fairly consistent. Really, in excess of 60% of IT leaders say defining their data center's platform strategy is their most difficult decision. So it's a very high percentage. There's a lot on line for the IT organization and IT leaders to get it right. What to move to the cloud, what to stay on premise, whether to go SaaS, or whether to go infrastructure as a service. And the data, surveys say up to 40% of this kind of boomerang effect, that there's been a service that's been migrated that does need to move back. And that's not a situation you want to be in. And that's kind of what the heart of this webinar is about, is knowing that these are facts, is kind of how you can minimize the risk. And it underscores really the importance of having a very good and thorough plan. And then when armed with knowledge of the available tools and doing the proper pre-migration assessments, testing, that you can sleep better at night and make sure that the migration, you pick the right services, you pick the right location of data centers, you pick the right cloud vendor, you've picked the right partners to work with. So a lot of thought, and I don't think this is news to our audience, but yeah. And I think so, Hendrix, you're gonna talk a little bit about what some of the user experience and how it impacts whether the migration is successful or not.
I mean, user experience is crucial. I mean, for cloud or any type of application. But of course, if you move your application from one location to the cloud, your end user will expect to have the same level of performance, or they don't even know that you're moving to the cloud, so they don't have to be impacted by that. I mean, there's a lot of statistics here. You can find them on different WPO stats, for example. But the thing is, remember one point is the kids born in 2000, today in 2019, they are target customers. And those kids have been born, they've seen the iPhone when they were very little. They've been born with all the digital transformation. They've been born with, decent internet connections, modern web design. So those kids, they expect a lot of things. And the first reaction, if something goes wrong, they're going to share it directly on any social media that's available in the market. So you have to make sure that you deliver a good user experience. And I think one of the best quotes to highlight this is Steve Jobs. I mean, you can work as hard as you can, but customers doesn't care about it. I mean, you can say, I'm resolving a lot of bugs. I've been changing this component, blah, blah, doing containers. And yeah, great, but I don't care. I was just going to measure, we are going to measure you on what you deliver. And this is exactly what happens on the market. So if you move to the cloud, I mean, you have to make sure that the user expectation is better or at least the same. You cannot deliver something that is worse than what you had before on your on-prem environment. I also, to highlight that piece on the user experience, I just extracted for a couple of references about performance issues. I mean, if you want to see, if you're looking for, by the way, any performance reference, you can search on wpostat.org. You will find a lot of different references, classes by years, and so on. So here I have 4 references. I'm not going to describe them one by one. It's going to take forever. But I'm pretty sure that most of you has heard about one of the most popular references is the study done by Amazon. I think it was more than 10 years. And Amazon did a study where they were measuring their response times and basically the conversion rates and the numbers that were doing with that response times. And they came up to the conclusion that every time the response times were decreasing with 100 milliseconds, they were losing 1% of revenue. And it's quite funny because Walmart, which is a quite new study, has exactly the similar similar conclusion. I say every 100 milliseconds improvement, you have 1% of revenue, and this is exactly the same thing. So basically, for any public websites or applications, you would be your business and the numbers that you're going to do will be directly related to your performance of the application. So don't jeopardize the business. And same thing if you're basically just in internal applications, you will just be stressing out your end users. They will be paying you. They will, because of the bad response times or the bad design. I don't know. So be gentle with those users as well. The other thing is, it's similar to the reference of Steve Jobs. We don't care about what effort you have, but one thing is, you can have the best coders. I try to recruit the best technical people in my team. I try to select the best technology of the market, and always just look at the latest things. But even if it's the best stuff in the world, there's always limitation. I mean, if you look at, for example, The Rock, the guy is super strong. He's going to have a limit. I mean, he's not going to be able to lift any load. There will be a limitation, and you need to know your limitation. It's part of your homework, because if you don't know your limitation, you cannot control those limitations. So that's the idea. So, Joe, going back to the consideration, what is the second consideration?
Yeah, absolutely. So we've talked a little bit about kind of some of the benefits, and we've highlighted that there are challenges, and so what are the real risks that are causing the problems, that are causing some of the rollbacks, and it's what has changed when you have on-premise applications. You have applications that are up in the cloud or aren't moving around or aren't kind of dynamic. You have more pristine kind of network conditions. Like in a on-premise application, you might have only a millisecond of latency, which is really, really small and really fast, and you have big fat pipes, and the network is deterministic. So a lot of times applications fail because they may be legacy applications. They're not optimized for the cloud, for the mobility of the cloud, for the distance of the cloud, and then just not doing the proper network assessments, because that's one of the biggest things that changes. Is now you don't know exactly sometimes where the application is going to be, and so doing that proper network assessment. And another thing is, a lot of organizations we're out there talking to, that they're relying on kind of their vendors and their vendor input, and they're not doing the proper testing themselves. They're oftentimes doing what is called proof of concepts or prototyping, and they're looking at just kind of a singular service from a limited number of locations and at a limited scale. So they're not doing the real world testing and testing at scale, testing with different network conditions. And another cloud is about kind of right sizing your compute, your storage, and especially your network resources. So you don't want to overspend on. The goal is to save money, but if you oversubscribe the network component, the bandwidth needed, you're losing money, or you're not getting maximizing your savings for moving to the cloud. So right sizing the number of data centers, the network capabilities, and then also just the lack of knowledge of, I know my vendor, my cloud provider, and maybe some consultants are out there to help me, but there's a whole bunch of tools that help you make sure these challenges are mitigated as well. And so there's just the knowledge of knowing what is available, what you can do when you're doing your study phase, what you're doing your pre-migration, and then keeping it going even after migration.
I mean, yeah, it makes a lot of sense. Especially, I think you make the point here, and we'll talk about later on. When you start rethinking, or and not every application is optimized for the cloud, and sometimes even if it's been designed, we have a natural human reaction to say, I'm going to take the server A and ask for the same settings in the cloud. And we'll talk about it later on, where you have to maybe rethink the overall architecture. And you mentioned about the network. I think there are a few things. There's still some organization that put a piece in the cloud, part of the architecture in the cloud. They are sensitive data, so they are keeping the part of the information in a separate data center hosted by themselves. So you have sort of direct link. So even if you're trying to size the networks, you have to think about those the two type of links: the links that will serve your customers, but also the links that will serve that will grab the data back in the data center as well. So you have to figure out couple of understand your application, in fact, before you do any migration.
Yeah, absolutely. And one of the big challenges, obviously, that we're not going to touch on too much today is obviously around security. So that's one of the biggest challenges. But then beyond that, you can see there's been some studies that otherwise like 47% kind of cite latency, which is okay. Now I've introduced a wide area network to my application performance. What impact does that have?
So the thing is, so you mentioned testing, and I think yes, any migration cannot limit on prototyping. You mentioned about it, and when you start migrating, you have to basically test. So obviously, I'm not gonna test about functional testing because I'm not an expert on that. I'm going to focus my point here on performance testing and load testing. And I think if you do any, you're going to secure your cloud migration. The idea is you have to test the proper things. And here to highlight what should be tested, I like to compare back testing to the Tacoma Narrow Bridge. So I'm pretty sure that you have heard about it, this bridge. So it's a bridge located nearby Washington. There, the story is that it opens in April 1940, and I think 4 months or 5 months later, basically it collapsed. And the funny story about that specific bridge here is they did some testing. So they knew that they had two constraints. So it's similar to our application. We know that we have some constraints, so we have some risks. We have to test it. And the first risk that they had was the ability to support heavy load. I mean, obviously it's a bridge. You need to support heavy cars, a lot of cars and trucks. So how do you do that? So basically, before the opening, they loaded the bridge with cars, trucks, buses, took some measurements, and they were able to say, yeah, everything was fine. The bridge is supporting heavy load, so we are good to go. Then the second requirement was the ability to support strong winds. So here, what they did, they had one day was a storm, so they decided to take advantage of that before the opening again. They put some measurements and see how the bridge was behaving with the strong wind. But there was no car at the moment. And what happened during the day? It collapsed. Basically, it was the combination of the two main constraints, heavy load and strong wind, that make the bridge collapse. And it's going to be the same thing with your application. It's good to test yours separately, each of your requirements, to at least validate that it's working fine. But at one certain stage, you need to combine those constraints. Otherwise, you won't be able to prove or reflect as something realistic. So when you move to the cloud, same thing, you have to pick some specific situation, understand that situation that you want to test, um, and then once you have properly modelized that situation with all the constraints related to it, you can be able to test and compare and validate. So when it comes to performance testing, so here I'm going to just highlight the standard workflow. I mean, most of performance engineers are working with this workflow. If you're doing eyes-on DevOps, the workflow will be slightly similar. It's going to be harder tasks of the project. So one of the, I think the most important task to test efficiently is the strategy. So here we want to move on the cloud. We have to pick one situation or several. I know I have some peak periods, and I'm going to select them and understand them. What are the scenarios used by my users during that specific period of time? What is the workload? How are those users going to ramp up? How are they interacting with my application? So this is basically a strategy. And this, each test that you have thought about or selected will probably answer one risk. So you need to have, in the cloud migration, to select something average and peak. And this will be basically the way that you will basically measure your baseline and compare with your baseline. Second step is you need to build scenarios. So you can script your scenarios on a load testing solution or record or whatever, and you need to correlate. Correlation is highly important. You need to import your data sets because obviously if you keep static or you're sending the same metrics back and forth, you will just prove that your cache is efficient, and we know that the cache is usually efficient. We want to do realistic load. Third step is prepare. So we need to have an environment, which is aligned with our production. So if you're going to migrate, if you either you test on a pre-production or environment quite similar to the production environment, or if you can do it in production, great, to do it during 90 hours, perhaps. Then you need to have a database which is also sized with the same amount of data. If your database is empty in your testing environment, then you will measure something which will never happen in production as well. You need to monitor. Monitor is, I think, the most important piece. You are putting constraints. You're going to break your system. If you don't know what's going on in the system, basically you're blind. You're not able to basically secure and validate what happens. And when it comes to the cloud, if you're IS, infrastructure as a service or platform as a service, there is always monitoring possible. There is also APM product that allows you to monitor those things. If it's a SaaS, okay, that makes sense. It's going to be tricky, but you have to work closely with your SaaS provider. Then we're going to execute the tests, analyze those tests, see how it goes, and maybe tunings. But when it comes to the cloud migration, we'll explain. We'll see that in a few seconds. The tuning aspects, we will do that once we are in the cloud. But before moving on the cloud, we need to have a first test to see how our current system is behaving. So,
sorry to cut you off. I was going to say that those are great comments about kind of the importance of design and design for performance, and certainly the network is another element that comes into play as well with the application design, because a lot of applications they weren't written for, they're written for LAN connections with really pristine links and really low latency. Let's just think about like an application. Let's say an organization is considering moving to something like a cloud object storage system where you can do searches based on metadata, and there's several kind of big players in this market. But what's going to happen to an organization if they move their storage of critical data, if they now put that in the cloud for redundancy and cost savings? How's how is the impact on the user going to be? And this is a pretty interesting chart here that really in about 5 minutes, anyone can kind of see this. When you have an application that's running on, let's say, a gigabit link, and assuming that it has about a millisecond of latency, which on-premise isn't uncommon, you're getting very high throughput. But now if you throw in, let's say, a 60 millisecond round trip delay, which is between two cities, let's say the round trip there, to make a request and back, just adding the latency alone drops the throughput of the application significantly if you're using a TCP type application. So going back to, okay, now I can retrieve the file I need or the information I need from the storage system in so fast, so quickly, or I can do a remote backup for disaster recovery, and it takes 2 hours, and now maybe it takes 4 hours. So those user impacts on that are interesting. And then also, what device? Maybe it's not just a business application, but it's something that's out in the market, and it's a SaaS application where consumers are using different types of devices, cellular devices. Maybe they roam to a place that's in 3G and they're moving. Now they have packet loss, so they have impaired networks. And so if you throw distance plus impaired links based on the device someone's using, you can see the throughput goes way down, the performance of the application. And we can just tell you, working with multiple vendors on these programs, that the applications can be tuned in how well they perform and how graceful they are when there's impacts to the network. And so vendors, just like any else in life, some vendors are great and some struggle. So it's a very important consideration.
And I think something that I would like to add is the latency, to remind you, if you basically have a HTTP application, latency will add between each network conversation. So if you take HTTP call requests, when you send it, you get a get, and then you get a response. Basically, technically, in terms of network, it's like 6 different conversations. So these 6 milliseconds of latency will be introduced on each of those conversations. So basically, if you have the response times with 1 minute, 1 second without latency, you can expect maybe a difference of 4 seconds or more with the latency that you measure. So latency is basically impacting a lot on the performance side, but also not only on the performance side. I mean, if your users are slower, it means you have more concurrent sessions on a dedicated node, a web server, for example. So it means that you're consuming more memory, more CPU, basically being more constraints to the overall architecture. So don't only limit the consideration that network is only impacting the response time or whatever. It's also impacting heavily the infrastructure as well.
Yeah, very good point.
So let's move on to consideration number 3. So Joe, you were saying that you were referring at the beginning with prototyping. I think here it's going to be dedicated to prototyping.
Yeah, absolutely. And really, this is, in my mind, one of the biggest mistakes that we kind of see organizations struggle with. And it was important enough that we think it should be a consideration on its own, because a lot of, frankly, a lot of it is based on kind of prototyping and testing at like a smaller scale. And the point is that, prototyping does not equal testing. And sometimes the two get blurred, because really prototyping is running kind of a single instance or a small scale of the instance. And it's kind of somewhat subjectively seeing how it performs. As an example, we've been working with one of the top financial institutes in the world and kind of helping them after they've rolled out a service now they're kind of it didn't really, they're rolling out a service to about 50 to 75 branch offices around the U.S. all the way, data center maybe being in New York, and having branches offices all the way to Hawaii. And they kind of, it was a new application they were rolling out to their branch offices, and they they did what a lot of organizations do. They started with having the application and then running it, a couple of branch offices and scaling it out to maybe half the branch offices, but not with all the users. And so they kind of just did a trial, and that turned out to get them in trouble when they actually then turned up to scale and turned everything on. They hadn't worked through. So a lot of times at smaller scale, the links are more guaranteed. You don't have the load on it. When you have the servers kind of moving around and not pinned up, the performance can vary. So, and some of the reason people do this is because, again, they don't know that there's tools available that help them go beyond kind of proof of concept. And proof of concepts are certainly important. That subjective input is a starting point, but it's not the ending point. Henrik, you want to talk a little bit about what proper testing at scale looks like?
Yeah, so testing at scale is basically, for those who have never seen load testing and the approach of load testing, is we are basically at one stage or another of the migration project, we will run tests. And the idea is we're gonna basically simulate different civil users that interact with the system. So the way it works is you have a product. So here it's gonna be, of course, NeoLoad. And you will interact with the load emitters. Load emitter is basically the component that will generate the load. So in general, one single load emitter based on the cloud, for example, simulate around 500 users. But if you have on-prem, depending on the configuration, you can go up to 1,000, 1,500 or above, depending, of course, of the configurations. The idea is that we are going to, if you have in your environment, that you have 50,000 users, for example, during a peak hours of interacting with systems, the idea is we are going to inject that load. So that means that you need to have the proper load infrastructure, so the number of machines required to stimulate those users, because if you use one single server for 50,000 users, you can imagine that you won't stress your app, but you will stress that machine. The other approach is there is the ability to simulate the load on-prem or from the cloud. So usually, in terms of recommendation, testing from on-prem or on the cloud depends on your app. If you know that your users is going to be hosted in your network, in your data center, and they will interact with the application hosting the cloud, then obviously you will have to host your load generators based on those locations. If you know that on the other side, if you know that your user, you have some sales based in LA, sales based in Paris, in Germany or Asia, then cloud-based load generators will allow you to simulate the load from those locations to be closer to the real network path that your user will utilize in their production environment. Before moving running on the cloud-based users, I would say test from on-prem, at least, to make sure that from your on-prem network, the app is responding. Because obviously, if you start running everything from the cloud, you will consume, machines, hours, which means money. So doing some really small tests on-prem is a way at least to validate that your app is running, that you have the ability to go further and run tests. So I would recommend to start always on-prem and then do some sort of hybrid load on-prem plus cloud, and because it will allow you to see if your user on-prem has a better response time than on cloud, that you can figure out that, okay, maybe there's a network issue here. It's just giving you more data and more information to figure out what's the problem. Same thing for the network. I mean, Joe, I mean, if you need to do a test to simulate what's going to happen, and you have user space or server space in different locations, you need to simulate the distance on that. No?
Absolutely. So many applications are global based, especially if it's a SaaS application. So, and that brings into play many different network types. You know, do you have an MPLS network? Are you doing something over Wi-Fi? Is satellite involved? The satellite market is becoming, if you've looked in the news lately, there's a lot of activity of satellite communications and satellite performance to make it more ubiquitous. And even within a geo, let's say you have, you know, you're based in Los Angeles, and maybe you have another database in the middle of the United States. You have one over in Europe for being closer to your users, to your internal users, to have disaster recovery, to have that span of distance for added protection. So the idea is the network in distance and the network type, whether it has impairments, which would be more prone for satellite certainly, and Wi-Fi and wireless networks. You want to be able to, in addition to testing at load, which Hendrik just alluded to, and you need that, and you also need the realism of the network. And you need to have the ability to think about, how am I going to do this? Okay, how am I going to spin up all these different kind of device types that have different network performance characteristics? How can I do that and do it at scale and do it in minutes? And that's why people prototype, is because they believe they don't have the ability to really bring the real world to their test environment. And there are capabilities to do it out there, and that's what's very important.
So last one is last piece. Looking at the time that we have left, so we have to build the data center to proper scale. I mean, we mentioned it at the beginning. When you're designing your application in your on-prem environment, we have the natural reaction to say, I'm going to buy a server. I'm going to probably add more CPU. I'm going to probably add more memory, probably add more disks, because we never know if we're going to do more things with that server. So at the end of the day, you can see that we have a lot of organizations that has for the database or for any other layers, huge servers with many CPUs. And it's similar to that the picture that you can see here on the left side here, to that small fish. It doesn't basically utilize the space that he has there. So if you're planning to move on the cloud, don't copy paste your hardware configuration directly to the similar hardware specifications. So that's true for infrastructure as a service, for example, because it's going to cost you a lot. I mean, remember, you're going to pay by the hour. So sometimes you have to figure out, okay, maybe for my database, I need to understand what would be how much resources I really need, how much disk or how much memory I really need, because I'm not going to pay 4 or 5 times more money for that server if I can optimize the cost. Other thing is Joe mentioned the locations. You can have, I mean, obviously you can select one data center for your user for the US market and one data center for the European and so on. And you can also imagine, even in one same location, several 2 different data centers and make a failover mechanism. Choose precisely where those locations, where those data centers are listed. There is, for obvious reasons, Joe mentioned it, and if you want to serve European user will connect, for example, in France or London or in Frankfurt, whatever. You need to make sure that they won't be impacted by latency, because latency is going to kill them for sure. Same thing at the bandwidth. The bandwidth is most of the time the network usage could be super expensive depending on the cases. So try to scale and size properly the network that you need, especially like we mentioned before, if you have a hybrid approach where you have a part of the architecture sitting in your on-prem environment. If you are putting some dedicated links or network links between your environment and the cloud, you can be very surprised that sometimes you can saturate those very quickly. Or maybe you don't want to be impacted by the next release of iOS, for example, where everyone's going to download and consume the network, and suddenly you don't have the network for the rest of the users. So some consideration needs to be also. Some things you need to consider that piece as well. So selecting which size of clothes you need, M, extra large, S large, whatever, is one of the key things when you go to infrastructure as a service. Even if you do platform as a service, you need some application needs some CPU, some stuff. So you need to probably size that and figure out that we can work on that environment. Consideration number 4. Yeah.
Yeah. All great points, Henrik. One thing I just looked at the time. Looks like we need to be a little mindful of keeping within the hour and leaving a little time for Q&A. So we might have to pick it up a little bit through the next couple of slides. But just on another big consideration is kind of what you're doing pre-migration. So it's kind of understanding your existing environment, and you can benchmark the performance of am I going to move this application that's on premise? Maybe it's a storage type application, or it's some internal application that I've been running in a certain data center, and now I want to move it to a cloud, or I want to have redundancy. And you want to have that kind of pre-migration baseline of what's the performance of the application, what's the user experience before you migrate, and then migrating, kind of testing before you migrate, and then migrating, and then again validating. So a very important thing is kind of where do you start?
Yeah, so I think that's the idea about building the baseline. So before you migrate, you need to understand what is the current situation. So for that, making a test to understand how the system is currently behaving when you have peaks or average production hours, to have some real KPI. That will basically, those KPI will allow you to define your SLO, your objectives for your migration. What is the number of transactions per hour, per second? What is the response time? What is the user experience? How much resources I'm consuming? So I need to get those objectives, because those objectives will be basically my KPIs and my SLAs that I will use for the same test that will be run after once it's been migrated. So baseline is a key component of the path of the migration. It's because you're taking a picture, and then once you have that picture, you will be able to compare that once you migrate it. You have the same quality of the picture.
Yeah,
and for the network,
I can go through this one pretty quickly. But again, you want to have you want to know what kind of network conditions you're going to encounter in when you migrate. And there's a kind of listed, I won't go through each one in detail, but there's different approaches that you can take. You can look to service providers. There's some open source data that has some limitations. The best data would be from a global monitoring system, from maybe a Dynatrace or whatnot. But if you haven't had one, you don't have one of those in place, it's expensive and time consuming to set up. And just a note, there is ability to kind of do it a little, to get very accurate results and do it a little bit more cost effectively. And Apposite actually has a tool that kind of allows defining the characteristics of the network, kind of real network, and what the conditions are, and then using that as an import source into your migration testing.
So last consideration is testing doesn't have to be difficult. I mean, like I said, you need to baseline. Then when you're going to run the same test over the cloud on your migrated system, you have some few considerations about this. And also above the just the pure validate the baseline, I would recommend other type of tests depending on the environment, your cloud environment. So the first test, the general recommendation. So first, you're going to generate the load into a cloud environment. Could be public cloud, private cloud. It could be SaaS. I will talk about SaaS later on, or IaaS or PaaS. Most of the cloud providers put some security. And if you generate lots of requests on a hit per second from, say, some couple of IP address of your load generator components, those traffic will be considered like a DDoS attack. So make sure that you white label those IP addresses. So that's the rule number one. Second thing, remove CDN, because here you don't want to stress the CDN. You want to just prove at least that your core application is working fine. Other element is the DNS. I mean, if you're playing with the cloud provider, they are using local DNS. Make sure that the local DNS that are properly sized. I mean, especially if the user is close to to your cloud provider. If you're generating the load from the cloud, same thing. If I'm selecting Amazon, I won't use Amazon, at least on a safe location, because it's going to be a local network, and I want to make sure that I'm going through the internet for my test. So that's the general one. Then you have two topics. The first, the auto-scaling, the elastic architectures. There are a few tests that I will add, especially to validate how your auto-scaling is working. So first, usually the thing is based on templates. I would recommend to tune the templates to make sure that it's properly sized. And once the template is done, you can enable the elasticity of the architecture. Though usually the scaling is based on thresholds, and the cloud, of course, if you use those type of features, new nodes can spin up in, let's say, around 5 minutes, but then the application needs to be launched in that node, and then once it's launched, the new node needs to be visible from the other nodes in that survey. So basically, it takes around 10 to 12 minutes, depending on the application. So when you have spikes, 10 minutes could be a disaster. So you need to make sure that the threshold that you define is fine-tuned to the load, to the spikes that you have in your production, to make sure that it's going to be spinning up in time for your spikes. The other thing is sometimes, I mean, if you look at Netflix, for example, they know that at 9 p.m. or 8 p.m., they're going to have a lot of traffic. So instead of running with stereo nodes, they are pre-starting specific nodes in specific time to make sure that they're going to handle the load. And then secret is degradation. You have load balancing, you have cluster, you have failover mechanism. Degradation tests are very important. I mean, if you want to take advantage of those cool feature that those cloud providers is giving us in our hands, we need to simulate the production problem, cut off a service, cut off a node, and see how the load is being properly balanced around the architecture. If I have failover or something, I need to validate the failover is working. When it comes to the SaaS, one gold rule is, remember, SaaS is probably part of the SaaS offering is common to most of their customers. But don't run load without alerting your SaaS provider. Your SaaS provider will probably give you a sandbox You won't be able to apply the same level of load. The idea is to test that the stats react properly, test that the user experience is really important in that area, and the monitoring is going to be difficult. But try to monitor your code, the thing that you manage, because you want to make sure that you're not delivering or deploying bad code, and that will impact user experience. So to that, we have built a joint solution with Neotys and Apposite technology to help you to secure cloud deployments. Really easy to deploy. You eliminate most of your risks. It's based on, of course, NeoLoad, the controls, controller, some load generators, and then you need the network emulator. So provided by Apposite. So it could be, you can basically show, it could be on several formats. I guess physical, virtual. It could be yeah. There is no different options with your components, and that will basically make the emulation. Is correct?
Yeah, absolutely. And I think another key point is right from through our partnership of working together, we've made the ability to control the emulation, of realistic network conditions seamless right into your user interface using kind of the API interface between the two products. And so that's how they kind of come together. So the offering, the value is the load and scale and the realism plus the network realism combined together. It gives the most holistic test solution for migrations.
So why NeoLoad? I'm not going to go deeper on that. I would say why NeoLoad? Why not? It's simply because NeoLoad. The NeoLoad basically what I'm not going to sell that, but most of our customers are saying that we are the most faster solution to build scenarios. I mean, you don't want to spend time building scripts or creating scenarios. You want to test. So if you are reducing that time, you're able to test more. Then you also, in terms of machine required for the test, will be very lower than a traditional load testing solution of the market. Technology-wise, we support most of the HTTP stack, all the package apps, so like Guidewire, any banking application, and CRM applications that could be, and also if you do any digital transformation, where you want to simulate user from mobile device, from IoT components, we can do that as well because we support also all the IoT stack. The load injection, like I mentioned, it can be on-prem and cloud. We can do the both. And we also tons of integrations. If you want to spin up and automate everything from a Jenkins server, you can do that as well, of course. So like Joe mentioned, integration, how it works, you're going to put the appliance close to your application. And NeoLoad is going to, one of the load generators of the test will control the appliance to enable, disable, add, or set a new type of emulation. So you could easily reproduce, rerun tests and reproduce some behavior because you will basically, NeoLoad will control the appliance directly.
Yeah, Hendrik, just very briefly, a little bit about Apposite. So we're more than a 10-year-old company. We've got 2,500 customers or clients worldwide. So really, all the leading kind of technology and enterprise brands out there have used Apposite products over the years. But just the picture down at the bottom kind of gives the most simplistic representation of what it does. It sits in between a cloud, a server, which for cloud migration might be Neotys NeoLoad, kind of simulating the client on the one side, and then there's the cloud server that you want to do the testing. And in real life, you're going to have a network and all kinds of network conditions in between. And how do you do that without having to go out into a real world where you uh, can't send the volume of traffic you need to benchmark the performance of the server of the application. So Apposite allows you to bring the network to your test lab. And your test lab could be on premise, or your test lab could be in the cloud. So it brings the network and all its imperfections and all its different types to you in a matter of minutes to be able to set up really what a real world network looks like and all its characteristics.
All right, just quick summary, quick wrap up, and then we could open the Q&A. So Joe, could you summarize the main points?
Yeah, absolutely, and I'll do this really fast because I think we're definitely over our time. But hopefully, we talked to the benefits of cloud, and we highlighted the many kind of risks that exist. And hopefully the point came across is don't necessarily rely on proof of concepts are important, but you cannot be relied on solely because they don't have the scale or the real world conditions. And there are solutions out there from companies like Neotys and Apposite that allow you to do proper testing. And ultimately, what are you trying to do? You're trying to it's a very important business decision for organizations, but it doesn't come without significant risk. And it's about helping you minimize those risks. And ultimately, when you pick vendors and when you pick which applications to migrate to the cloud, that you're picking the right ones. And when they're deployed successfully. Your internal customers are excited and rewarded, and your external customers as well.
All right, thanks, Joe. Thanks for this. You're watching this webinar. So let's open the Q&A. So if you have any questions, please drop them. So I'm going to open the Q&A panel. See the question that has been asked. Up here it is. So I have one question for you, I think, because it's related to network. Joe. So how closely can you replicate different network conditions you may encounter?
Yeah, that's a great question. So the answer is very closely. So we've been doing this for a long time, and we've got a lot of data on, what are the characteristics of a high performance Wi-Fi network? What's the characteristics of a poor performing Wi-Fi networks? What happens if you're on 3G? What happens if you're on 3G and you're on a train and it's moving and you're kind of having intermittent network connectivity? So we've studied data, working with many customers over the years. So we've got some of that knowledge base, but more importantly, the time that it takes to kind of replicate all those different network types and conditions and performance, from bandwidth to loss you might experience, other corruption, latency, certainly jitter for video streaming services. It can be done in not in days, months, weeks. It can be done in minutes. So pretty thorough.
So I have one question related to you as well. What type of clients have you worked with on cloud projects? I think it's going to be both of us. So you can answer it, and I can answer it from my end.
Yeah, as I said, a lot of them. We worked probably more than a third of our business is working with enterprises that are doing some type of cloud or data center relocation or migration. So really, all the big kind of financial type companies and a lot of retail companies. We've also worked with a lot of vendors. So vendors that are are selling solutions like cloud object storage solutions that they want to be able to prove to their clients that their object storage solution in the cloud scales well. So a lot of leading enterprises and a lot of a lot of the vendors that have cloud offerings.
So from my end as a Neotys, so of course we sell a product and customer can do so. We don't control how we use it, but we have big names of the industry that are utilizing a lot of cloud components that use our product on a daily basis. Otherwise, we've been helping a lot of service-based, big service-based streaming companies to size and tune their architecture. So I'm not referring to the leader of the streaming, but the other ones. And also we have a couple of other big gaming players that we have helped as well on the sizing and the tuning of the cloud environment. All right, next we have another question. So it's going to be related to NeoLoad. How do you build scripts in NeoLoad? So it means that first of all, what I would recommend is to download our product and have a look at it. We have a premium edition. You will see that we don't script. The way we've been designing NeoLoad is have easy to use, very quick learning curve. Everything is mainly through graphical component. We recently released as code approach. So this code approach is more designed for early performance engineering, where you need to test in early phases the microservices or a few components in a component level testing. So in dev cycles, for example. So usually those tests are really simple. So I think building scripts for those tests makes sense. But when it comes to testing very complex application with a lot of WebSockets and streaming and scripting that and coding that is going to be a nightmare. So recording and designing from the traditional GUI is going to be much more productive in any case. But yeah, you can either code or so code. There's two formats. There's a JUnit, so Java-based library, and we have a YAML description file as well. And otherwise, you have, of course, the GUI, traditional GUI, to do that. Joe, there's another question: how is Apposite system installed? So I think you briefly introduced that on the previous slide, but could you be more precise on that?
Yeah, absolutely. And I think you mentioned it at one point, Hendrik. So we have both physical and virtual and cloud-based versions. So we have a full range of very kind of low cost or very affordable and highly portable that can, like, maybe half the size of a laptop that can be moved around, that supports physical device that supports speeds of one gigabit. And then we have a little bit more high-end appliances that have a little bit more precision and capabilities, and they range from 1 gigabit to 100 gigabits per second physical appliances that can be 1 or 2U, and especially the higher-end ones are used by our developers and maybe service providers, the 100 gig. But then in the last year, we've really moved to supporting virtual editions that run on the most popular hypervisors. And we're also moving to having cloud editions. So we've got Amazon support. So it can be spun up into an instance that's running in the cloud, and all the type of testing can be done directly in the cloud. And we'll be adding other ones, Microsoft Cloud Support and Google Cloud in the near future. So both kind of physical and virtual appliances, what we support, Hendrik.
So I have basically the same, quite similar question for NeoLoad. Is what type? You mentioned you have a cloud node generation. So who is the cloud provider, or what cloud provider you support? So it's so the load generation that we provide in our cloud platform Basically, you don't need to have AWS account, Azure account, and so on. We basically manage everything for you. And we are working with 8 different cloud providers. So it could be Giant, Google Cloud, Azure. There's a lot of, we have a dedicated team that basically is managing new providers. So at the moment, we are providing to our customers 59 different locations around the globe. And we are showing basically which zone, like I mentioned before during the webinar, don't inject the load on the same provider and same locations, and then your environment, because basically it can be local load, and that's why we're showing which provider we're using, so to make sure that you're going to send some external traffic on your application. I think, I mean, I'm looking at the watch, so we are way over the time. So if there is any other questions, we will, of course, answer them later on. So I would suggest to finish this webinar from now. And I would like to remind you as a action plan, go to our NeoLoad, and you can basically evaluate our product, but I would recommend also to have a look at one of the cloud migration data sheets that is available on our website. So the link here, I think you're not able to click, but we will obviously share the slides afterwards. But there is, you can also look at this data sheet as well. Otherwise, I would recommend to look at Apposite Technologies website. You can look at to have more the information about vTropy and the emulation. And also we have, like I mentioned, the premium edition on Neotys if you want to have a try on NeoLoad in neotys.com. So Joe, I would like to thank you for this presentation. It was really useful and interesting from my perspective.
Yeah, thank you, Hendrik and Neotys, and thank everyone for attending. Bye.
Thanks, and have a great end of the day and or great morning, depending where you're based. Thanks, and you. Bye.
Goodbye.